We tend to think of the brain as this super stable, reliable machine, right? But at the same time, it's unbelievably flexible. It can switch from one thought to another in a split second. So, how on earth does it manage to do both? Well, the secret lies in a fascinating concept called metastability, and it's the key to understanding the brain's incredible dynamic dance.
So think about it. How can your brain be solid enough to reliably recognize a friend's face, but also fluid enough to have a sudden spark of creativity? I mean, it needs stability for sure, but not so much that it becomes rigid. And it needs to be flexible, but not so much that it dissolves into chaos. That is the central puzzle we're going to unpack today. To really get to the bottom of this, we've got to look beyond these simple black and white ideas of stable or chaotic. It turns out neuroscientists have realized the brain doesn't just pick one. It operates in this really special state, a kind of dynamic middle ground that gives it the absolute best of both worlds. And here it is, the core idea, metastability. It describes brain states that are, and I love this phrase, long-lived but transient. Let that sink in for a second. A thought is stable enough to be useful, that's the long-lived part, but it doesn't hang around forever, that's the transient part. This is what lets our brain explore all these different patterns of activity, all these different thoughts, without ever getting permanently stuck on one. Now, to really get a grip on metastability, it helps to compare it to something it's not, multistability. Just imagine a multi-stable system is like a landscape with a bunch of really deep valleys. Once you're in one, you are trapped. You'd need a huge random push, what scientists call noise, to hop out. A metastable system, though, it's totally different. It's designed to keep moving. You can hang out in one state for a bit, and then poof, you just spontaneously roll on to the next one. Okay, I know that might still sound a little abstract, so let's use a really powerful analogy to make this crystal clear. We're going to paint a picture of all the brain's possible states as a kind of vast, rolling landscape. So picture this state space as a huge map of every single thought you could possibly have. Any given mental state, like, say, you focusing on this right now, is like a little ball rolling through that landscape. Wherever the ball goes, your thoughts follow. Simple as that. All right, step one in our analogy, a simple, totally stable system. Here, the landscape just has one super deep valley. The ball rolls down to the bottom and that's it. It just stays there. It's completely stuck. This would be a really, really boring and inflexible brain. Okay, moving on to step two, a multi-stable system. This landscape has a few of those deep valleys, so the ball is stuck in one, but if some big random event comes along and gives it a hard enough kick, it might just pop over a hill and land in a new valley. So it can change states, but it needs a serious disruptive push from the outside. And that brings us to step three. This is where the magic of metastability really shines. In this landscape, you don't have deep pits. Instead, it's full of these gentle, shallow depressions. Some scientists even call them ghost attractors. The ball or thought can linger in one for a little while, but the slopes are so gentle that it just naturally, effortlessly rolls on to the next one. And that is what allows for the fluid, continuous stream of consciousness we all experience. Okay, so this landscape analogy is great, right? It gives us a way to visualize this fluid movement between thoughts, but you might be wondering, what actually creates that landscape? What are the mechanisms under the hood that are driving this whole dance? And this isn't just some vague theory. Nope. Researchers have actually identified several real, concrete mechanisms that can make this happen. Now, the names are a bit of a mouthful for sure, but don't worry about them. They basically just describe different ways the brain can be wired. Some rely on the brain's own background randomness to help thoughts kind of hop from one state to another. Others describe these really structured, almost predictable pathways that guide thoughts in a sequence. A really good way to think of this is like they're different kinds of engines. Some of these engines are powered by the brain's natural inherent noise, and that's what keeps everything moving. But other engines are more structured, creating these well-trodden paths through that mental landscape that guide our thoughts in a reliable order. So we've got this really elegant theory of how the brain works, but what's the payoff? Why does any of this actually matter for our health, for our consciousness, for just our day-to-day experience? Well, this is where it gets really, really cool. This quote from a really foundational paper just says it all perfectly. For the brain to do everything it does, to learn, to adapt, to be creative, it absolutely has to operate in these fleeting, transient modes. A brain that gets stuck Well, it's a brain that can't really think.
And get this, metastability isn't just an abstract idea. It's something we can actually measure. It's a real biomarker for brain health. In a healthy, awake brain, metastability is high. No surprise there. But look what happens when someone is under anesthesia or has a traumatic brain injury. It plummets. The brain literally becomes less flexible, less dynamic. But here's a fascinating twist. More isn't always better. It looks like there's an optimal range, a kind of Goldilocks zone for metastability. If you have too little, the brain becomes rigid and slow. But if you have too much, which some studies have linked to psychosis, the brain might become too fluid, unable to hold on to a single coherent thought. It's all about that perfect, finely tuned balance. So the big picture, the main takeaway here, is that metastability isn't some niche, obscure topic. It seems to be absolutely fundamental to pretty much everything we care about: our very consciousness, our ability to solve problems, how we age and develop, and even understanding devastating disorders from TBI all the way to schizophrenia. Which leaves us with one final kind of mind-bending question to chew on. If our entire conscious experience is just a ball rolling through this vast, ever-shifting landscape, just a series of brief visits to these shallow valleys of thought, what does that really say about the nature of a stable, unified self? What does that say about who we really are?